Hello everybody, so today we're going to continue looking at solving equations. So this first example, we want to solve the following equations and then we want to compare the two and we want to see what's different between them. So you'll notice in number 1, first thing I got to do is combine like terms. So when I combine like terms, I get 7 minus 3n equals negative 14. So next, when I subtract 7 from both sides, I get negative 3n equals negative 21. And then to close this out, all I got to do is divide both sides by negative 3. And when I do that, negative 21 divided by negative 3 gives me 7. So n is going to equal 7. Now you'll notice over in the second example, what's different here? Well, I have variables on both sides of the equation. So the first thing I have to do is get the variables on one side and then get the numbers on the other. So the first thing I'm going to do is I'm going to subtract 3k from both sides. And when I do that, I'm going to get something that looks a little bit more familiar. I'm going to get 2 plus 2k equals negative 6. So now that the variables are on one side, I just solve like I have been. So I'm going to subtract 2 from both sides. And I get 2k equals negative 8. And then to finish this out, when I divide both sides by 2, I'm going to get k to be negative 4. All right, so the only difference now is I have to get my variables on one side first before I can actually solve this equation. So let's do a couple more examples. If I were to get the variables on one side here, I'm going to subtract 3k. Actually, hang on. This is the same example as number 2 over here. Okay, so no need to do that twice. Just same as example 1, number 2. Okay, so let's look at number 2 here now. All right, so here you see I got distributive property. Well, I have to do the distributive property first. I got to clear those parentheses. So if I do the distributive property on the left-hand side, I'm going to get 30m minus 18. And if I do the distributive property on the right-hand side, yes, there's a fraction, but I can deal with that. A third of 24, or 1/3 times 24, is going to give me 8. And that m's coming along for the ride. And then 1/3 times 12 is going to give me 4. So now I need to get the variables on one side of the equation. So I'm going to subtract 8m from both sides. I get 22m minus 18 equals 4. So my next step, I'm going to add 18 to both sides. Then I get 22m equals 22. So to finish this out, all I have to do is divide both sides by 22. That's going to give me m equals 1. Okay, so go ahead, practice these two on your own. Then I'll throw up the work in a quick second. So there you can check out the work on this one. All right, number 1, we end up with a fraction, and number 2, we end up with x equals negative 11. So I want to point out this step. Okay, remember, so here you'll notice we have 3 minus x equals 14. And so when I get the x by itself, it's still negative. It's still negative x. So in order to undo that, I have to divide both sides by negative 1. And when I do that, x is going to equal negative 11. So make sure you copy this work down. It's good to go. And let's move on to the last example. So here we're going to solve each equation with variables on both sides. So we're going to do what we just did. Okay, so if I do that distributive property, and then I got 5x plus 5 equals 15x minus 12 minus 10x. So then if I continue solving this, left-hand side is good as is, but right-hand side I need to combine like terms. That's going to be 5x minus 12. So now what happens is I need to get the variables on one side But notice, you're subtracting 5x from both sides, and your x's are going to totally go away, and it's going to leave you with something that says 5 equals negative 12. So because the x's went away, that means that x doesn't necessarily equal something. So now I need to look at this. 5 equals negative 12. Is that true? That is not true, so this is a false statement. And because it's false, then I can say that this has no solution. Or NS, okay? So, if you ever get a statement that is not true, you can say that that has no solution. There's no value for x that's going to make this equation true. So let's see in the second example, when I simplify everything, okay, when I combine like terms. So if I stop right here, you'll see the left-hand side and the right-hand side are the same exact thing. Now, if I were to take this a step further, like we can stop here, but just so you can see what's going to happen, if I subtract the variables to one side, those are going to cancel out. I'm going to get negative 10 equals negative 10. And then if I add 10 to both sides, I'm going to get 0 equals 0. So you could have stopped here, here, or here, because you'll notice that the left-hand side is exactly the same as your right-hand side. 6b minus 10 equals 6b minus 10. Negative 10 is the same thing as negative 10. 0 is the same thing as 0. So this is always going to be true. And because it's always going to be true, we say that this has infinitely many solutions. So no matter what value of b you plug in here, it's always going to equal the right-hand side. The left-hand side and the right-hand side are always going to equal. So this only happens, these two types of cases only happen when you have variables on both sides of the equation. Okay? So go ahead and practice these and see, do you end up with a true statement, an always true statement? Do you end up with a false statement? Or do you end up with a variable equal to a number situation? Alrighty, so I want to go back to this real quick. I know I just said this will only happen, no solution or infinitely many solutions, that this will only happen if you have variables on both sides. That's not necessarily the case, okay? If you have a false statement, because this can happen whenever, if you have a false statement, your variable goes away and whatever's left over is a false statement, that's no solution. If you have a true statement, if your variable goes away and what's left over is always true, then you're going to have infinitely many solutions. All right, so check out this worked out practice. Okay, you notice in the first one, the variable doesn't go away. And so you can actually say x equals something. But in the next one, okay, which is actually number 2, okay, you'll notice the variable goes away and what's left over is negative 7 equals 3. Well, that's never going to be true. Negative 7 never equals 3. Therefore, that's a false statement, so we say no solution. So make sure you write down your questions. As always, be good. Do good. I'll see you when I see you.